In this video, we are going to fabricate perovskite solar cells. A solar cell is a device that converts sunlight into electricity. The cost of fabricating one cell is less than 50 cents. It only takes a few hours, and we use standard laboratory equipment. This experiment is highly appropriate for general chemistry students to learn about this state-of-the-art renewable energy technology. The perovskite layer absorbs light and creates electrons in the conduction band and holes in the valence band. On one side, titania selectively transfers electrons from perovskite to the FTO anode. On the other side, copper thiocyanate selectively transfers holes through the carbon particles to the FTO cathode. Once we have electrons on the anode and holes on the cathode, we can hook it up to power an external device like an LED. First, we are going to use a model to demonstrate the fabrication of the solar cell. We start by placing an FTO glass with the conductive side facing up. Next, we deposit a layer of titania covering 3/4 of the surface. Then we coat the surface with perovskite light absorbing material followed by a layer of copper thiocyanate. To complete the device, we sprinkle carbon particles on layer and close it with another piece of FTO glass with conductive side facing down. We use binder clips to hold the device together.
To make a perovskite solar cell, we need 2 pieces of FTO glass, titanium, perovskite, copper thiocyanate solutions, and carbon powder. To prepare the titanium solution, we use 5 ml of ethanol, 0.3 ml of titanium isoperoxide, and 0.1 ml of hydrochloric acid. After adding the 3 together, we let the solution stir at room temperature for about 10 minutes. The second solution we have to prepare is the light-absorbing material perovskite. To make a 0.5 molar perovskite solution, we will need to mix 140 mg of lead chloride and 240 mg of methyl ammonium iodide in 1 ml of dimethylformamide solvent. The resulting reaction needs to be stirred at 80 Celsius until a homogeneous yellow and transparent solution is formed. Lastly, we will make 0.05 molar copper thiocyanate solution by stirring 6 mg of copper thiocyanate powder in 1 ml of dipropyl sulfide solvent at room temperature overnight. The final solution should look colorless and transparent.
In the first step, we will determine the conductive side of FTO glass. To determine the conductive side, we set the multimeter to resistance mode, plug the 2 leads into the multimeter, and measure the sheet resistance on each side using the probes. The uncoated side will not give any value. To deposit the titania layer, place the FTO glass on the benchtop with the conductive side facing up. We deposit 1 drop of titania solution onto the glass and spread it across the surface with a glass pipette. Then we remove the tape entirely and place the glass piece on a hot plate facing up. We heat it at 450 degrees Celsius for about 20 minutes and let it cool down for about 10 minutes. We put 1 drop of perovskite solution and spread it across the surface with a pipette. We roll the pipette over the glass several times to create a uniform, smooth film. We keep the uncoated surface covered and remove the excess tape. We place the glass piece on a hot plate preheated to about 110 degrees Celsius. We wait until the film turns completely black and let it sit there for another 10 minutes. We deposit 1 drop of copper thiocyanate solution and quickly spread it across the surface with a glass pipette. Now place the glass piece on the benchtop, scoop a small amount of carbon particles with a spatula and sprinkle them onto the glass piece. Finally, we close the device with another piece of FTO glass with the conductive side facing down, and we hold the device together using binder clips.
We measure voltage by turning the multimeter knob to the 2-volt mark. We measure current by turning the knob to 1 milliampere mark. Using a very similar procedure, we make high-efficiency cells in our research lab. Here we created a small solar panel that can light an LED.